time is negative, that means that your particle is slowing down, it's losing more and more velocity. Okay, it's losing more and more velocity. Now imagine that you are talking about, for example, you are talking about a war scenario, okay, in which it's pretty much important to track down what you call track down the the enemy plane. Okay, and not only so you will be very much interested in that. Okay, where it is going, how much distance it is covering, what is the velocity of that aircraft, what is the acceleration of that aircraft, is it slowing down, is it moving faster, and then you want to predict the position. So here's an interesting thing. Then you want to predict the position of that aircraft in, say, upcoming few seconds, and then hit a fire actually. So if you want to bring that aircraft down actually. So what you're going to do, you want to predict the position, okay, you want to extrapolate the position of that aircraft, okay, and hit the fire button so that you can track it down and you can bring it down actually. Are you getting the point? You have to extrapolate. So all this can be done through analyzing what you call the velocity of the particle, okay, the velocity of the object. And as I said, this particle is an abstract word. It could be a big thing, could be a small thing, could be an aircraft, it could be a car, it could be a human. So you can model it. This will always work, okay, in most of the cases. Alright, so here is the situation where I would like to analyze, for example, let's do a concrete situation, analyze the motion of particle. Okay. So imagine you are looking at the screen of the radar, and you have spotted, for example, an aircraft, and that you want to track actually. And it turns out that the particle, okay, for example, okay, the particle is kind of on your coordinate axis moving in this manner actually, okay, something like that. Okay, so you tracked its position at different points and somehow you got this curve. And once you got this curve, you're going to say, I have seen something like this. I can model this by, say, a cubic equation. So imagine that you modeled, or your device, or your software, or your computer, tracked the position of the particle and created a model for you. And that it turns out that the position of the particle at any time t, okay, can be given as, say, S can be given as, say, f of t, that is a cubic function t cubed minus 6t square plus 9t. It's a cubic curve actually, something like that. So you can plot it in Desmos to have a more concrete look. So this is representing what you call the position of the particle at any time t. And then you want to ask, for example, different question. So one thing that you can ask is that, okay, find the velocity. So compute, say what is the velocity of this particle at any instant t. Okay, so if the position of the particle can be modeled through such a polynomial, then what would be the velocity of the particle? So the velocity of the particle is going to be, obviously by definition, computing the derivative of it. And once you compute the derivative of it, what you're going to get? You're going to get, say, 3t square minus 12t plus 9. So we know how to do the differentiation. Okay? Now, this piece of information is an interesting piece of information. Say, the distance is in, so let's assume that the time is measured in seconds and the distance is measured in meters actually. Okay. So if you have this model for the position of the particle, position of the aircraft, you can ask, okay, what are the velocity of this particle, so you computed it. And once you have the velocity of the particle, you can ask different questions. Okay, what would be the velocity after the 2 seconds you started observing it actually? So the v of t, so if you want to compute, for example, velocity after the 2 seconds of your observation, then you need to just compute what we call v of 2. And I can compute this v of 2 as 3 times of 2 square minus 12 times of 2 plus 9, and it turns out to be, a number that is negative 3 meter per second. Okay? So that means that the distance that the particle is covering, its rate is negative 3 meter per second. So it's slowing down. It's covering less and less distance actually at this rate. So this is what the velocity of the particle is. What would be the velocity at, say, after the 4 seconds? Okay, so if I ask velocity at 4 seconds, so what would be that? So it's 3 times of 4 square minus 12 times of 4 plus 9 and equal to, what do you call 9 actually. So this is what we're going to get. Okay, so 9 meter per second. When you look at this instant, so at time 2 your velocity was negative, and at time 4 your velocity is 9 meter per second. So that means that somehow the velocity is increasing actually. So the particle is gaining the velocity. The particle is accelerating actually. It's covering more and more distance as the time passes actually. So this is what that you can conclude. For example, now we can ask the different kind of question. Can you spot the particles? So here's the question actually. When looking at this position, when the particle is at rest, okay? When the particle is at rest, so when the particle would be at rest, so the particle would be at rest if it is not moving at all. And when something is not moving at all, what should be the velocity of that object? So that its velocity should be 0. So in other words, particle would be at rest if you can compute the instant time, which is not known to me for now, is at this instant, what the velocity of the particle is 0. So you want to know such instant where the velocity of the particle is 0. So how you can know it? So the velocity of the particle is 3t square minus 12t plus 9 equal to 0. Okay, and you can use your what you call quadratic equation skills, and it turns out that t equal to 1 and t equal to 3. Okay, so keeping in view this velocity, okay, keeping in view this velocity of the particle when the particle is at rest. So it was at rest at first second after the observation on radar, for example, and after the 3 seconds. Okay, first second. So in other words, this discrete piece of information gives you, so through all this information we will make a beautiful picture actually out of it, and you will see that all this discrete stuff is going to give you some pieces of information. By the way, I'm doing example 1 from Calculus Concepts and Context book by James Stewart from 3.8 section. Okay, so this is example 1. Now, the next question that we would like to answer is that when the particle is moving forward, and whatever that means, so forward could be that, okay, when that aircraft is moving towards our territory, and when the aircraft is moving away from our territory. So when the particle is moving forward and when the particle is moving backward. So by just looking at these two information, can we deduce that when the particle is moving forward and backward? Okay. By particle, as I said, here I mean aircraft. You can mean anything. Okay. So when the particle is moving forward and backwards. So, by the way, what would be the meaning of moving forward and moving backward? So imagine yourself sitting on a car. So when you will move forward and when you will move backward actually. So to move forward, so you have to either keep your velocity constant, like should be non-zero, okay? So it should be positive, so the velocity should be positive, okay? Could be a fixed number, it could be something that is changed. So in other words, you will move forward, you will keep on move forward if you are moving with, say, velocity of 50 kilometers or above actually, per hour, something like that, okay? So moving forward means your velocity is positive. And what you need to do when you are moving backward? So what you need to do what? You need to slow down and then move backward actually. So your velocity should be what you call negative. So I can interpret, for example, in this situation by forward movement as the velocity of the particle is moving positively, as the velocity of the particle is moving positive and the velocity of the particle is moving negative, means that the particle is moving what you call backward. And when the velocity of particle is 0, we already interpreted that this means that particle is at rest actually. So how can I know that when the velocity of the particle move forward and velocity of and when the particle is moving forward and particle is moving backward? So in this case, I need to, rewrite. So I need to just analyze my what you call velocity. So the velocity by factorization can be written as 3 times of t minus 1 times t minus 3. Now, you will move forward if the velocity is positive. Now tell me when the product of these numbers is going to be positive. 3 is already a positive number. T minus 1 is a number that could be positive, that could be negative. And t minus 3 is another number that could be positive and that could be negative. Now this would be positive, so the v of t would be positive if all 3 of these factors are, if these 2 factors are both positive, they have the same sign actually. So either they both are positive or they both negative. Because if the t minus 1 is positive and t minus 3 is positive, their product would be positive. And if the t minus 1 is negative and t minus 3 is negative, their product would be positive as well. So you're going to see the particle will move forward when the velocity is positive, and this is positive if and only if t minus 1 is positive, and this is an important thing, and t minus 3 is positive. Okay, or the other situation could be that t minus 1 is negative and t minus 3 is negative. Now I can interpret this as, what would be the meaning of t is positive and t is bigger than 1 and t is smaller than 1. So t is bigger than 1 and t is smaller than 1, and t is smaller than 1, t is smaller than 3. Now if you look at, for example, the timeline to really see this set, that okay, what are the set of times where the particle is moving forward? Particle is moving forward. So if I draw this line, so this is 0 and 1 and 2 and 3. Okay. So what do you mean by t bigger than 1? So the t bigger than 1 means everything that is here. Okay, everything that is here. This is t bigger than 1. And what would be the meaning of t bigger than 3? So everything that is here. Now, when the t is bigger than 1, t minus 1 would be positive, and when the t is bigger than 3, then t minus 3 would be positive. Now tell me when the both would be positive. So the both will be positive here. So I can say that t minus 1 and t minus 3 are positive when t is bigger than 3. And you can check it actually. So if you take t equal to 4, so 4 minus 1, 3, positive number, and 4 minus 3, 1, positive number, and 5 and 6, so you can check on actually both. So I can conclude that after 3 seconds, the particle is moving forward. It's moving forward. Okay, the aircraft is moving towards us. And what would be the situation when the particle is moving backward? Okay. So this would be the case when either there could be another situation actually forward, that either both of them are negative. What do you mean by both of them are negative? So if t is less than 1 and what do you call t is less than 1 and t is less than 3, so I can make another picture 0, 1, 2, 3. T less than 1 means all this stuff, and t less than 3 means all this stuff. So when the both are agree, in other words, that when the both are negative, so it's really this notion actually. So you're gonna say that t minus 1, t minus 1 and t minus 3 are negative when t is less than 1. So what would be the summary of moving forward when the particle was moving forward? So the particle was moving forward or is moving forward, okay, when the velocity of particle is positive, and which is the case if before 1 second it was moving forward, and after 3 seconds, the particle was moving forward again actually. So an interesting question would be, what was happening between 1 and 3? So let's see what is happening between 1 and 3. First 1 and 3 seconds. Now again, this is the interval between 1 and 3 when the particle is moving backward actually. So it's like running away from a side. Okay. So v of t 3 times of t minus 1 times t minus 3 is negative. Now when the product of two numbers is going to be negative, if one of them is positive, another is negative. So you can have two situations. So either t is less than 1 or t is bigger than 3, or t is bigger than 1 and t is less than 3. But this is nonsense actually. This doesn't make sense. So if t is smaller than 1, how can it be bigger than 3 actually? So this is nonsense. So the only sensible choice is this actually. So t is bigger than 1 and t is less than 3. So that means that t is sitting between 1 and 3. So if you choose a number between 1 and 3, okay, then t minus 1 is going to be negative, and t minus 1 is going to be positive, and t minus 3 is going to be negative, and hence the velocity is going to be negative. So by just looking at these numbers, we kind of track down that when the particle was at rest, these are the instant t equal to 1 and 3. When the particle was at moving forward, so before first second and after 3 seconds, and what was happening between 1 and 3 seconds is that the particle was moving backward actually. Okay, whatever that means. Now let's try to make a sketch actually. The next part is really that is sketch this information. A sketch of particle movement. Particle motion. So what would be the sketch of it? So if I say that this is the instant t equal to 0, this is instant t equal to 1, this is instant t equal to 2, and this is instant t equal to 3. Okay. So what was happening in this interval between 0 to 1? So this is the situation when t is less than 1. So we said that the particle was moving forward actually. Okay. Particle was moving forward. And then what happened? At this point, the particle is stopped because t equal to 1 and t equal to 3 are the points where the particle has stopped its motion. And then what happens after the 1 second, between 1 to 3, that the particle moved backward actually. Okay? The particle moved backward. Move forward and then move backward actually. So it moved for 1 instant forward, and then the next instant it moved backward. Okay, and then and at the next instant, it at say t equal to 3, so probably this would not be a good idea to put t equal to 2 and 3 here. So it moved forward at t equal to 1 is to stop, next second moved backward, and then 3 seconds has passed. So at rest, so you can also say that it kind of rested at t equal to 3 and then moved forward again after the 3 seconds. And after it has kept on moving forward. So this is the sketch of the motion of the particle actually. So it moved forward in first second, in second second, and then it started moving backward in second and third second, and then at third second it rests, and after the third second it started again move forward and moving forward. Okay. Now, what more questions we can ask a hell lot of questions actually by just posing a simple model that you have for the position of the particle. So if you have a position of the model for the position of the particle, and by model I mean an equation that models the position of the particle, then you can answer a lot of interesting questions. You can also ask the questions about, for example, the total distance that it traveled, for example, first 5 seconds. Okay, so here's the interesting question. What is the total distance that has been traveled in the first 5 seconds? Total distance in first 5 seconds. Okay. Now, I need to draw a timeline. Between 0 and 1, it was moving forward. Between 2 and 3, it was moving backward. The particle started moving backward. And then after 3, it again started moving what we call forward. So we need to take care of what you call the total distance that it covered actually during first 5 seconds actually. So what you need to do, the total distance it covered. So first we will compute this distance and this distance and this distance actually. Okay. So the total distance, for example, that covered in the first interval is going to be what? So I need to compute, for example, my S is f of t. So this is like representing the position of the particle at time t. So, on average, what distance we covered during this interval. So you need to compute what do you call, so during 0, during the interval 0 to 1, the particle covered like f of 0 minus f of 1 distance. And what is f of 1? So we know the f actually, just substitute what you call 1 into it, and it turns out to be 4 minus 0, and it turns out to be 4 meters. Then it moved backward, okay? Then, it covered some distance. So what would be that? Say, for example, f of 3 minus f of 1. Then again, you can use the formula for f and compute f of 1 and f of 3, and it turns out to be 0 and minus 4. F of 3 must be 0 because the velocity of particle at time instant 3 was 0, so the no distance was covered, and minus f of 1, which is minus 4. So it's going to be 4 meters again. And how much is the distance that was covered between say 3 to 5 seconds? It's f of 5 minus f of 3. And what is f of 5? So you can substitute 5 into the formula and you can get 20 minus 0. So that's 20 meters. So how much particle has covered distance between 0 to 5 seconds? So it's 4 plus 4 plus 20, so it's 28 meters.